In this video, we're going to look at evaluating the database structure and validation for Phoenix Circus. We need to consider how well our database structure has minimised data duplication and how well a database structure meets these requirements. Modules have a result of unclassified pass, merit or distinction. Trainees' name must be present and learners can study a number of modules. You'll notice, if you've looked at any of my previous videos, this is exactly the same in as much as the evaluation is split into two main parts. The first part is how well your database structure has minimised data duplication, and the second part is how well your database structure meets these requirements. So we're going to tackle this evaluation in those two main parts, and each part I'm going to subdivide just to make it easier to write the evaluation. So this is the first part. We need to evaluate the structure minimises data duplication. And again, if you've seen my videos before, we need to look at what is data duplication and give an example. What's the purpose of normalising data and the relational databases? And look at what we've ended up with following normalising the sample data. And we need to name the entities, the primary and foreign keys and the relationships. Make sure you use examples from your sample data to support your explanations. Link the evaluation to your database structure. Here's the paragraph describing data duplication. So data duplication occurs in a database where data is stored a number of times in one table. An example of this would be where Boateng studies 3 modules. And if this person's details and modules were stored in one table, the details about Boateng, i.e. surname and date of birth, would be duplicated. The issue with data duplication is that it increases storage requirements and it's difficult to keep the data error-free. For example, if Boateng's first name needed to be changed, it would have to be changed in 3 records. Here's the second paragraph of this first part. The purpose of normalisation is to organise the data and minimise data duplication. Each attribute is stored only once, with the exception of foreign keys. These are copies of primary keys and are used to create relationships between tables. Using relational databases and normalising data eliminates data redundancy. This will ensure the data is error-free and storage is used efficiently. And this is the third paragraph, evaluating how our structure minimises data duplication. I've normalised the sample data and identified 4 entities: trainee, module, level and trainee module. Each entity has a primary key. For example, trainee has a primary key of trainee you know. On the many side of the relationships, there is a foreign key that links 2 tables together. For example, in module, there's a foreign key of level. Level is a primary key in the level entity. There's a one-to-many relationship between level and module. Level can be allocated to a number of modules, and a module only has 1 level. Attributes are stored only once in a table, with the exception of foreign keys. The next part of the evaluation looks at, does the structure meet requirements? And again, this is split into 3 subparts. The first part is to evaluate the result is unclassified pass, merit or distinction. Learners study a number of modules. And then the final part is the trainee's name is present. Again, only write about what you've been asked in the activity. Use examples from the sample data to support your explanations and link your database structure and validation used. Here's the first paragraph about the second part of the evaluation. One requirement for Phoenix Circus was to ensure data integrity and make sure the data was accepted. Trainee's surname must be stored. I've used validation to ensure this. In the validation rule, I've used is not null to make sure the user enters the trainee's surname. An error message is displayed if the user does not enter the surname. The training record will not save if the surname is not entered. And here's the second paragraph of this second part. Another example of ensuring data integrity is where I've provided a table lookup value list for the result. The user has to select a result from the list. If the user tries to enter something not on the list, an error message is displayed. The user is not allowed to add to the list, as I've used limit to list in the field's property. And here's the final paragraph of the second part. A trainee can study many modules, and a module can be studied by a number of trainees. Learning to juggle is studied by 2 trainees, and Boten has studied 3 modules. This is a many-to-many relationship. A new entity was created between trainee and module. The primary key is made up of trainee no and module no. Together these 2 attributes are a primary key, but they are foreign keys individually also. As foreign keys, the fields are set up as combo boxes, table lookup foreign key. This means that only trainees that exist in trainee and modules that exist in module can be selected or input. A record for a trainee that does not exist or a module that does not exist cannot be saved. An error message will be displayed. This is the final video covering part A of the syllabus. In the next video, I'm going to start looking at the forms or the interfaces that need to be created for part B.